All right, well, let's go back to where we ended. We ended with a load test. So what we're going to do is we had several errors. We're going to go ahead and start running it again.
Oh, what do you mean errors?
Errors here.
How can we get errors? We've just run a simple test.
I know. We ran a simple portal read. It was just a load of portal page for 25 users.
That it? 25 concurrent users? Because that's nothing.
It does seem something's wrong.
What does SPO1 tell us?
Processor percentage total is whacked.
Oh.
And we're still getting also a .NET CLR security, which, by the way, .NET CLR security is almost always a dead giveaway. Something's going on in processor land. Can be memory land, but generally it is processor land.
So our boxes are tanking on processors already.
I'm going to run it again here, Steve.
Did you upload a photo?
Yeah, that's what I was. Did you not see me at break? It's uploading a large photo.
Right. So obviously we're preempting this, right? The servers over there should not be struggling with 25 concurrent users, yet they are. Something's going wrong.
Yeah, it's your.
So let's not.
A really common problem is shared disk. You have a bunch of VMs running on a single set of spindles, shared disk, and that's a really, really common problem. Have you guys seen that before? Where Exchange is using the same disk as SharePoint and it's virtual host and everything's really slow.
So you're basically accusing me of creating a really bad disk.
So let's do this. Let me first just see. We'll see where it's going. Now you'll say, why are you running Task Manager if you're running load tests and you're capturing counters? It's because it's real time and it's easy. So let me give you an example of real world testing here. And I'm going to come over here and open up SP1 as well, and I'll just open up its Task Manager also. And I just kind of want to get a feel for what's going on while we're running the test, and plus it cures boredom while you're running the test. So you can actually go look at something moving on a screen. It actually does help, strangely enough. And we'll go back over here to our test rig, and I'm going to run this test again.
Because it would be very easy at this point to assume that it's the SharePoint front-end servers that are the problem. Or it would be also very easy to just turn around and say, actually, we think it's the SQL server that's just not doing its thing. In other words, the disks are just not performing right. So we're running the test now, are we? We've launched it again?
Yeah, so okay, we're running SQL. Maybe that does not look like a SQL problem. 1% CPU usage, 23% memory. Perhaps it's the disk. One of the things to keep in mind is just because you have plenty of processor and memory available on SQL doesn't mean you don't have an I/O constraint, which is the disk. And how would we find that out, Steve? I'm just going to open up perfmon. So just type in perfmon.exe.
So even though the Visual Studio load test has got all those performance counters that we've specified, we still want to now go onto the server itself, and we want to see the performance counter for, in this instance, the disk access time, just to see what's going on with that SQL server itself accessing those disks.
I'm looking for 3 specific counters. I'm looking for average disk queue length, and then actually let's go to current disk queue length. This should be no more than 2 per usable disk in the array. So if it's a single disk, you shouldn't see this number going over 2. And if you're arrayed 5, it's probably somewhere around 6 or so. But there's actually a formula. If you look in our SQL session early in the week about RAID penalties. So let's first get processor time off the screen. We're now looking at, it is not the disk, Steve. It is definitely not the disk.
1.3 is our average disk access.
So disk queue is really, really, really low. The last is 0.15. So see, here's what we've looked at: SQL Server, real time, not memory, not processor. Now we know it's not disk. So maybe it is over here on this other server though.
So if it's not SQL, then obviously what we're showing here is that the traffic from the front end server is probably not getting to SQL.
This CPU is 100% though, Steve.
On the SQL?
No, on our web front end. Our web front end here is 100% CPU.
So we're tanking a web front end already at 25 concurrent users. That's not good. What about the other web front end server? What about SPO2? Are we tanking
let's
that?
take a look at SPO2.
Because these are load balanced. These are meant to be load balanced, right?
It's probably PEG 2 then.
Well, if that's pegged, we've got a real problem.
25 users is not a lot of users, is it? Concurrent. That'd be about 250 users if you go on 10%.
Yeah.
Concurrency.
200 users, 250 users.
For the task manager. It is actually pegged, Steve.
So we've managed to break it already. We haven't done anything. So something else is wrong.
So we are getting 12 and a half users per server. Awesome, eh? And how much did this rack over here cost?
Yeah, I want my money back.
I want my money back. 25 users. It's more common than you can think. And we're going to bring Bob up in a minute to talk some too. But it's really common to see servers that don't perform any better than this right off when we first go in. And is this a SharePoint's fault, right? So what do the users say? Well, SharePoint's slow. SharePoint sucks. But it's not a SharePoint problem. Let's take a look at the server configuration on these. So if we look at performance here, we can see how many CPUs do we have? Well, we have one. There's one enough.
Obviously not.
Obviously not.
But in a virtual environment, how many people here have virtualized SharePoint environments in the room? Wow, okay. So a lot of virtualization going on there. How many of you have the ability to define what your virtualization team provisioned for you? So you have the control and telling them what they need. And that's a really important aspect of virtualization, because we need to say, depending on the type of server role it's going to be, not just memory allocation, but cores as well. So we can see here that we've got a single core that's causing our bottleneck, regardless of the test that we're running. So we're going to need to fix this, I think, at some point, Ben. Else we're just stuck, mate.
And what do we do then?
We need to call our virtualization guys.
All right. You can also take a look at, in addition to disk queue length, look at response times to disk. We're looking for 10 milliseconds, no more than 20 millisecond response time to disk. 10 or 20, you're okay. If you get up around 50, you're kind of in trouble. And sometimes we see it up even closer to 100, and that means you're, I don't know the proper word in England, what is that? But you're in trouble. There you go, we'll leave it at that.
Bring up the load test again. So some of the things that key indicators that we're looking for on the load test is the request per second, the page load times. So even, we know that the CPU is being throttled. And on the side here, we can see that the counter sets coming back with things like request per second and page load, and we can get those statistics out of this. What we should be looking for from an average hit like this on this type of infrastructure, we should be somewhere around the 240, 260 requests per second as a minimum on this type of environment, just hitting home pages and simple access. So we're really low here. We're at 171 we're currently doing, and that's pegging it. So no matter what we do now, we are not going to increase that. In fact, the more concurrency we try and do on it, it's going to be irrelevant, because it's pegged to maximum. So this is not a great number that we've achieved.
One thing, though, is much better than SharePoint 2007 is as we're pegging this, SharePoint doesn't crash, at least. I mean, we had some of those issues in past versions, like in 2007, where if I pegged the application pool, it would crater.
Good point.
Craters, so I was at NASA for years. Crater is bad, right? Implode. So it would crater on us. 2010 is much more stable than 2007, and part of that's IIS, I believe, is just more stable as well.
So, I'm thinking, actually, we could bring Bob up to talk about the testing whilst we do the server shutdown and restart.
Yeah, why don't we do that?
Do you want to come?
Yeah.
So let's bring Bob up. Bob's Microsoft PFE in America. He's very nicely offered to come in after his night out and come and talk to us a little bit about what he's been doing in the States and some experience. Sarah, if you want to go and disappear and shut our servers down, what we're going to do whilst we're doing this is we're going to shut the SharePoint servers down, we're going to add a second core, and we're going to see if that solves our problem.
Where are we at with this guy? Let's minimize this. Just give me back to the desktop.
So what we're going to do, let's just get rid of that test, we don't need that anymore. And
Yeah, we're good.
HPAL. All right.
So for performance testing, everybody familiar with PAL?
I would
Sure.
suggest a lot of people are not.
Good. All right. Well, it's not good, but try and fix that today. If you go to Coplex, there's a tool called PAL, free download. It's one of the few tools we'll tell you to download to test with your environments. It's real simple to use. All right. So a guy named Clint Huffman, he's PFE also out of the U.S. He built this. He never has to do any more IP again due to this tool. But the beauty here is, what we do is I do a lot of risk assessments. So on top of the wraps, the reports, sometimes it's easier to go back and actually show detailed information about what's happening in the environment, threshold, disk thresholds, things like that, latency. This tool will actually take you down to the drive letter to show what's going on. But how many people use Perfmon? I saw a few hands. How many people like to add those counters by hand? No? Let's fix that today. If you click on threshold file, so say you want to go into your environment right now or when you go back next week, all right, you want to run these perf tests. You can go through here, go right to threshold file. See this? Get a whole list of thresholds we can grab. So in our case, let's choose the SharePoint 2010, and we'll export that. I'm going to put it on the desktop. All right. So we open this. We've got all the counters baked in there already.
And that's really important, isn't it? Because a lot of times we get people saying, well, I'm not sure what counters I even need to be looking at. Where do I start, right?
Yes, we've helped with that.
Another thing that's useful is, anybody use SCOM, MOM, System Center Operations Manager? The management packs are actually quite good, and it lists not only the performance counters, but it also lists the event IDs it's looking for. So it can actually track event IDs on these servers to make you aware of situations. So even if you're not running SCOM, not that I'm saying you shouldn't, but even if you're not, you could download your MSDN version, load it up, go into authoring, look at the counters and the event IDs you want, and then you could take those and put those into your, if you're running Tivoli or NetIQ or some other system. That's generally what we do if a client doesn't have SCOM. But we've just exported the rules out, essentially.
All right, so we got that file, we created that file. You open up Perfmon. Go into data collection sets, user defined, should be empty. Click on new. All right, so we give it a name.
Name.
Usually server name. Call it name. How's that? Yeah, we'll do something else. All right, so we want to choose create from template. All right, keep it there. Click next. So you got your basic system diagnostics and system performance. Click on browse. Go back to your desktop where you save that. And click finish at that point. So you're all ready to go. The other important piece here to remember is once you click on this, you want to change the output file. So you want to change from binary down to CSV. So you're good to go here. So you can take that file, put it on all your SharePoint boxes. You can also create a counter for SQL, put that in your SQL boxes. When we do risk assessments, we run them for about 24 hours. All right, so we get everything going on from morning logins to backups at night. Usually at nighttime, we're going to see our issues with disk because of backups and all the other processes going on. So they're expected. If we see that kind of stuff happening during the day, as we were mentioning, shared disk, you'll see that if you're running a virtual environment, if you see shared disk issues going, or if you see disk issues going across the line on all the boxes, it's usually because your virtual boxes are all pointing to the same LUN, sharing the same disk in that instance.
Yeah, that's one of the big things we see with virtualization, is where we've got shared LUNs being used across different VMs.
And it's also shared network. So the telltale sign that I've noticed is generally the disk queue goes real high if we have overused a disk. We see on network drop packets. If we're dropping packets on the network interface, that generally means we've oversold, just like the cell phone companies, mobile companies do to us on towers. You're essentially overselling your network bandwidth within your farm. So those are kind of the two key things to look for. And this is especially important if you don't manage the virtual environment. We have a lot of clients where the network team says, no, our CPU is fine on these servers and memory. It's your fault. It's your problem. So we dig in deeper and we start showing them, no, I've got Q links way up here. I'm getting terrible response time from disk. It's now your problem again. So those are a couple things to look for if you're in a virtual environment.
All right, so let's pretend. All right, so we ran this test for 24 hours. We stopped the capture. We go and we grab that CSV file that we created, and we bring it over to our machine we're running PAL. Now, the important thing here also, don't run PAL on your environment, on your production servers. You will tank it. You will copy that CSV file over to your local box and run it from there. So once we do that, we're going to come back. So say we just open this up again. We've already got the capture completed. We'll go through and find that file that we ran and brought over. So just do a search for it. We'll capture that. You want to again go into the threshold file. Make sure you choose the counters you ran. So you're going to run this for SQL and for SharePoint. So you're going to run this multiple times for each box. Questions. This is an important piece also. You want to make sure you match what's in your environment. So if you have 4 CPUs, you want to mark down 4 CPUs. If you've got 8 gigs of RAM, you want to change it to 8 gigs of RAM. Hopefully you're running more than 8 gigs of RAM in your production environments also. How many people are actually running 8 or 4 or 8? You'd be surprised. I run into that a lot in some environments, and they're wondering why they're having performance issues. There's a good document out there called Recommended Software and Hardware Recommendations. 4 is for a test environment. Once we go through here, we'll change the number of processors. 64-bit right now is pointed to false. We'll make sure you set that to true. Total memory, you want to add your memory there. If you're using RAID drives, he just threw that in there not long ago, so you can put the RAID drive configuration. Output options, I usually leave this alone. File output, because I do a lot of these captures, I make sure that I change this to the actual server name. Q is basically what's going to be happening. That's the PowerShell command that's going to happen to execute this. Then you click on execute. All right. Once you click finish, go up a PowerShell window. It's going to start running through the tests. This could take for a while. This could take up to an hour, hour and a half, depending on your files. But 24-hour capture is generally about a good hour. I don't have a sample report to show you, but basically a nice report shows all your, if you're in red, you'll see some red in there. We'll be careful. We look at minimum, average, and maximum. Generally, we want to focus on the average times, especially for latency. If we're going past 15 milliseconds to 25, if we're hitting 25, I take a look and see how long it's actually happening. It could be just a spike. If I'm seeing it happening for a longer period of time, we want to investigate a little bit deeper. All right, 15 is good though. Any questions? Download this. It's free.
It's free.
We're not charging you.
Free's good.
Free is always good. So what we're addressing here is it's all very well and good as building these load tests through Visual Studio, but we still have to think about how we're going to monitor additional servers and services at the back at the same time. These are ways that we can do that, record it, and use it all as part of our ammunition. As we know, when we try and buy hardware in IT, then we obviously have a problem in terms of getting the finances to do it. This is ways that you can prove that you need the hardware. Thank you very much, Bob. Much appreciated.
Thank Bob.
So the server should be up again.
Desktop ended.
So are we just going to run the test again and just see what it decides to give us? Shall we just see if it's made any difference at all? Surely, and adding a core can't make that much of a difference, right?
There we go. A shot, mate.
One of the things you can do here in the display pane, when Ben brings it back up, is you notice how there were like those 4 different windows there showing different stuff. It's not very useful. So I usually take it into a more single pane view, and then you can just have your counters shown on there for real-time viewing.
And it takes it could take up to 30 to 60 seconds for the graph to start
All
displaying.
warming up and loading. So you'll see on the bottom, which ones have we got? We've got the Servo 1 counters listed by default. So when you start creating the load test, you can actually, once you've started running them, change the counter sets. We can add custom counter sets in there. And next time you run the load test, it will remember the counters that you were looking at live as well on here.
That's right.
So what about Task Manager, Ben? Should we see what
go
Task
take a look.
Manager's doing?
Yep.
Yeah, let's just see if we're starting to peg it already, because we should see that. So SPO1, which one's this? SPO1, yeah?
I don't know we started the test. I think it's warming up still. Let's make sure that we have it going here. Like I said, it could take up to 60 seconds to get the rig up and going and testing. You'll know it begins because you'll see a plus sign show up over here beside the counters, beside those computers and the overalls. Once those turn to plus signs, your test has begun. If you did this against a live server system, you'll know when the user calls you and asks you why they can't get to the server. So much like Bob was saying before on the PAL tool, don't do this during production hours. However, you almost have to do it against your production servers at some point. We essentially break every server farm we build at some point to know where the thresholds are. So understanding that baseline, and then we generally back off about 20%, and that's what we're monitoring for. So about 80% of those threshold values, we want to be getting emails or SMS when those values are hitting that 80%. When it hits 100%, it was too late. If it's 100%, make sure your resume, your CV is not in SharePoint. You always keep that somewhere else. There it goes.
There we go.
As you can see, it's all you, Steve.
I'm seeing no processor yet.
It's awesome.
Let's go and have a look what SPO1's doing.
It's better.
And it's better. Much better, because now we can see we're getting the peaks and troughs. I'm not too concerned about those. Like Bob was just saying when he was talking about, you're looking for those gaps, those percentages. If we get the odd hiccup, that's fine. We don't want flatlining. So we're getting 67, 60, 74. That's not too bad. That's not scary at the minute. Although, having said that, how many concurrent users did you do, Ben?
25.
25.
It's 12.5%.
So let's see,
Thereabouts.
as it's running, what our requests per second are doing. We've not improved our requests per second. Oh, it's going up a little bit now. We're getting a bit of caching. Notice that if we get rid of these counters here, let's just get rid of these. I don't want to show those. What I'm going to do is just add some of the counters from some of the boxes that we're monitoring to do a comparison. So I could say, I don't know, add the user time on there for the percentage processor time. And we could also go into SQL, and we could add the counters from SQL if we wanted to, for example, for the processor on there. And maybe we'll want to look at memory usage as well. For example, just looking at different various comparisons. So what we're looking at is when we start looking at the counters on here for real-time monitoring, we're looking for those bell curves as we start to introduce more issues, or maybe want to launch a crawl on the servers. We should see, for example, the SQL one increase if we were to start launching an application crawl.
One of the things, once we've done this, is to also take a look at if this is a publishing site. So you have the publishing infrastructure. We can get these tests. That's how we start tweaking beyond just adding processor and memory, to these servers. We actually need to start optimizing the pages and the list inside of SharePoint itself. So turning on output caching. How many people have used output caching? Object caching, blob caching. So those are the big three. We can start tweaking those three caching, and you could get significantly improved numbers here. So we've taken something from 25 out of the box on a small virtual to 100 just by modifying the cache settings, okay? Now, caching has a few issues here and there, so be careful. It's not like Ben and Steve said go back and turn on caching, so we'll do that. Do be aware that there could be some issues with caching because you're not seeing freshness of data. So, for example, if I'm caching a list, for example, on my home page, and I'm only refreshing it every 60 seconds, it could be out of date. It could be up to 59 seconds old. So there are some issues with caching, but you are going to see a large increase in performance as you turn on caching as well. So the output caching is your page caching, Your object caching is your object model, and then blob caching is the actual binary objects. It will actually take large images that your users will eventually put in SharePoint. It'll put a copy of those on the web servers. So the web servers aren't constantly going to SQL Server to get those images. They're now stored on the web server itself. And it'll do that for you under the hood.
Yep. Yep. So notice here, this is our load test that we built. You can see all the parameters for that load test that we went through that wizard. These are all the parameters that we can change. So for example, if I click on constant load pattern, you'll notice on the right-hand side, we've got the variants for that. We can do step-based, goal-based. We've got our constant user count at 25. So what we're going to do is we're going to have some fun.
We're already having fun.
Well, more fun. More fun than you're allowed
Okay.
to have on a Wednesday morning in London when it's raining. So we're going to go for 150 concurrent, right? We're going to step it up. Let's see if we can flatline it again. And we'll run that test again.
And what you're going to see is essentially what I call the footprint of SharePoint. You're going to find that about 6 to 8 gig of RAM and 2 cores is kind of the minimum. You know, when Microsoft puts the minimum hardware, it's for a reason. And you can actually run load tests against those posted minimums. You get a huge performance gain. We see huge performance gains going from 2 processors to 4. Somewhere around 6 to 8 gig, depending on your antivirus on that server and your management tools. Huge performance gains going from, say, 6 gigabytes to 12. And way more than double. Because you have essentially the minimum CPU performance that SharePoint requires. How many service applications you have loaded, how many instances are on that machine. There's a lot of factors. But if you're doing any type of beyond just really basic SharePoint, you're in the 10, 12 gigabyte of RAM space, most likely. As you can see here, we've added a single processor, and we've greatly increased the performance of this server. If we were to continue to add memory and additional, go up to 4 processors, you'd see this thing handle probably around 200 to 230 users concurrent per server. So a huge difference between 1 and 4. It went from, what was that, about 6 concurrent users on 1 to about 226 on 4.
So let's just wait for it to kick in. I think we should interject it with some sort of additional chaos theory in here as well, shall we, halfway through this, just to have another level of chaos. Which one should we throw in? Should we throw another one in? Should we try and tank SQL as well? That could be quite fun. Or we could just do a crawl. Neil was here somewhere. Hello, Neil.
Hey, Neil.
Did you scale your search out of stuff? All your crawls on different boxes? They are, aren't they? Yeah.
We have the query running, right?
Yeah.
What's the crawl server? Okay. SPO3 and 4. When you're thinking about farm performance, we ran these tests in the afternoons, and they run well, and then we'll see huge issues in the middle of the night. And when we look under the hood, what's going on, or I'm sorry, under the bonnet. Getting better. Yeah? Don't kick me in the boot. Is that right? No, I don't know. Anyway, because we have antivirus running. So we'll see antivirus scans running every night from like midnight to 2. At the same time, we're running backups from like midnight to 2. At the same time, we have usage analysis running from like midnight to 2. So do take that into consideration. And don't have all of these items running from the middle of the night from midnight to 2 or midnight to 4. Especially, so if you actually ever had to get users on there at the same time you're doing antivirus scans, at the same time you're doing insert miscellaneous operational task. Bob?
I want to mention also disabling the real-time scanning of the SharePoint.
Oh, excellent point. There's a list on TechNet that talks about disabling the scanning on several directories. The search directory, and I'm sure Neil could speak to this if you asked him afterwards, we've seen up to a 50% performance penalty if we do not have exceptions on the search directories where it's building the indexes. Same with the Excel temp directory, your temporary ASP.NET, and several others. But if you look on TechNet, there's a list of exceptions. How many people have their exceptions built for their SharePoint servers? Okay? And if you don't, it's probably killing your performance. In fact, I can almost guarantee it. If you go back and you actually put those exceptions in place, it's really common, by the way. That's how we know it almost always speeds up server farms. It's the first thing we usually take a look at. So thanks, Mr. Fox.
So
Crazy Leica.
you can see here that even with 150 concurrent users, we're not tanking it yet. We're almost there. So by adding that second core on both web front-end servers, we've really been able to step up the concurrency onto those two boxes. And we've not just been able to double the amount of users. I mean, we've gone from 25 to 150 concurrent users, and we're still not flatlining it. So we're going to have to probably step it up again in order to flatline those front-end servers now. So that's a massive leap just for adding 2 more cores. 1 core per front-end server has made a massive difference to that throughput.
And you can see here that it's clearly not a memory issue on the box. It is a CPU. So adding CPUs is really the only way you're going to resolve this.
So how long's left of the test now? Should we tank up? Let's launch a crawl whilst we're doing this.
I'm just going to take a look quickly here at we know it's processor, but let's just make sure we don't have a physical disk issue going on. I'll show you this quickly.
You're determined to prove my disks are wrong, aren't you?
I am, because so often at clients it is. I'm going to take a look at the disk queue length, all instances. I just want to make sure that we're not getting these really high disk queue lengths. We don't. And you'll see it up here in the 20, 30, 40 range. And don't be shocked if you go back running these tests and you see your queue links in that range. It's people overdrive virtual all the time. So you're saying now, go kick off. Here, I'll give it back to you, Steve.
No, go for it. So you can go into Central Admin, yeah, and launch the, go into Search, and how many crawls have we got, Neil? Do you know? How many should we launch? Lots? 2, anyway. Okay. That'll just go for 2.
Oh, that's enough for at least, 30 million items?
And there's Gary's nicely created service apps, all good naming conventions. No GUIDs, right? That's the way we want
Teams,
SharePoint.
is there a preferred content source? Okay.
Okay. So what we're doing now is we're interjecting an actual application process into our load test. So even though it's not part of the actual load test itself, we want to do a what-if scenario. One of the nice things about creating load tests and then rerunning them from your baseline is that once you've saved them, you can just keep running them in different scenarios. And obviously your web tests are different small tests. We put those web tests into different load tests, and we can run those load tests multiple times in the different strained conditions. And so what we're going to do now is, it's not finished yet, has it? Mm-hmm. So we're going to run it again?
Yeah, do we want to add the...
Oh, the counter set.
Yeah.
Of course. Right, so we're initiating the search crawl. So one of the things that we should really be looking for to grab data as part of our load test is those counters for the specific application that we're now trying to get statistics from. And on the left-hand side, what Ben's doing here is he's adding a custom counter set. So there is no counter set for SharePoint Search that's given to us in Visual Studio.
The SPO 4 or 5, which one was it?
I think it was 3 and 4.
What are your crawl servers, Neil?
3 and 4.
3 and 4?
For the quick, if we're doing the test for the crawls, yes, 3 and 4. So we can add 3 and 4 now into the load test parameters on the left-hand side, so we can add more servers that we want to monitor. And then secondly, we're going to create a new counter set, and we're going to go to the servers and browse the counter sets on that server and locate them.
I'm going to slow down a second. Steve and I are making this look really, really simple, and you're going to go back and you're going to be like, because it is just a little bit different than a lot of the other Microsoft applications. So it's a lot of right-clicking where you wouldn't think you'd be right-clicking. We're going to add a custom counter set. And I'm just going to call this
SharePoint crawl or something, SP crawl or
Search. Sorry,
search. That'll work.
I'd already done it. And what I want to do is add counters. Once again, this comes back to server permissions. You've got to be able to read the remote registry of the server we're looking for. SPO3. I hate that it does that.
You do that every time.
I do. SPO3. And it's actually going to go to that server, and it's dependent on the services that are loaded on what you'll get result back. So if you go to a server without search, you won't see the search counters. If you go to one with search, you will see the search counters.
And depending on whether you're looking for crawl or query, right? Because not every box is doing both. So you're going to have some dedicated query servers. Some might be dedicated crawl servers.
So we are here looking for the OSS search gather. Yeah, Neil's shaking his head yes.
But SPO3, is that the one that's... Yeah, that's
Yeah, and then I'm looking for... What's the best one?
He's just giving you that one because he knows it works.
Docs filter rate. And then I'll tell you what we'll do. So then we go back to our other servers. I should have added that first. You're right? I didn't do that.
So now we've created those custom counter sets. We can add them into the servers themselves that we've added and say, we want you, server 03 or 04, to have that additional counter set now as part of your monitoring process.
So I'm going to go to 3, SPO3 and 4, which are now no longer here, which I find odd, but that's okay. And I'm going to choose search for those servers. See what we did? We added a counter set, and now I'm going to add SPO3 or 4, and hopefully my crawl isn't done already, but that's okay if it is. And I'm going to choose search on those. And let's go ahead and just run this again. And tip here, once it's running, if you'd like to get to the graph screen earlier, you can just open up that in progress on the bottom of the screen there. You can double click it and get into the very cool window here.
How long did the crawls take, Neil? Do you remember? Yeah, let's do it again.
We'll see where we're at. They're done, so we'll start these again.
Because nobody ever starts a full crawl in the middle of the day, right? We don't do that. But the thing is, it could be anything from Performance Point, Excel services. We might be deploying one of the new application services into the business, and we want to test what that application impact is. Can we justify using existing hardware? Are we going to be running it on dedicated application servers? Maybe we can't get the funds for those application servers. One of the great things about this tool and what we can do with it is actually proof of concept to go back to the business and say, do we need more money or not?
And you can go well beyond. I mean, you could have Excel services, Performance Point, dashboards on web pages that you've created a test. And you can use those pages to test your service applications, your caching for Excel services and Performance Point. If you've done per user caching, however, to get an accurate non-cached result, you may want to come in and wire up a CSV file for like foreign space authentication. So you have a different user coming in every hit to that server, especially things like Performance Point.
Yep. Yeah, and one of the things that obviously a common approach to SharePoint is, can we get away with 2 boxes at the front end and put everything on it and just obviously share the services between those 2 front end servers? For a lot of companies in the UK, anything below sort of 1,000 users and below, that arguably is perfectly suitable, even 2,000 and below architecture, right? 2 servers, load balanced. We've got search, we've got collaboration running off them. We shouldn't really be hammering it. We've just proved we can have 150 concurrent connections still. But the problem is, it's not just about loading everything onto those 2 servers, because over time you are going to get more people adopting and using those services. So in your initial baseline, you'll go, oh look, Excel services is fine, we've got all this collaboration traffic, the publishing pages are loading quickly. 4 months down the road, you go and load a bunch of third-party vendor tools, maybe doing some workflow integration. And like Ben says, you then go and buy some client tools that then start hitting the servers more often for some offline integration with Outlook tools, whatever. Within the space of 6 months, you've gone from everything baselining quite happily across 2 boxes to suddenly flatlining it with all these additional components you've now added. Then you need to go back to the business and say, oh, what do? We need more servers. They say, sorry, you're out of time. That's next year's budget. So now you've gone through this process of saying, I wish we'd tested that what-if scenario 6 months ago. And we'd have known then not to do that. Or get more budget at the start. Of course, in IT, we always do that, right? We always get as much as we possibly can from day one. If we can get $100,000, I'll get $100,000 and buy 16 servers. I don't care. I'll use them at some point. So is it running now?
It is, but Neil's configuration was so masterful, we cannot get the servers to spike. So
Have you optimized search too well?
he did. We cannot get it. You messed up our demo, Neil.
So even launching a full crawl in the middle of the day with 150 concurrent users, we still can't spike it. Yes.
I'm impressed. I am impressed.
But it's my discs.
That's true. It is yours. I'm sorry. It is your disk. There we go. Very good.
But we need to think about this stuff, because when we're looking at the processor memory and utilization of all these services, we need to know it's good. Because if we don't know it's good, how do we know when it's bad? And so even though we're not tanking it, that's good, because we know now that in a normal situation, if these things take place, it's not an issue. And that's what we're
Could we load a large picture on here?
We could load a big picture on there if you wanted to.
Where was it?
We probably didn't have one.
Oh, I meant to load it. Matt sent it to me. I'm going to stop this. I'm going to abort this test. And what we're going to do here is we're going to create a new load test. So, for example, here, let's... and once again, we'll not use think times. Worst case scenario. This is where we'll get back into step load. You know, we had been talking about just a constant load, and if you had a requirement of it was 50 users, it was 100 users, we usually just test for the 100 users, right, directly. But if you're not sure where your servers are breaking and you have no idea, one way to do that is through creating a step load.
Yeah, so let's do the step one this time and show the bell curve as it comes across. So we want to see trends now. We're looking for trends. We're looking for what happens when we do that same test of the same services or the same web test running, but in a more realistic environment, say first thing in the morning. Because again, a load test, you don't just want to run every day at the same time. That's not real world. So we might want to run the load test at 9 o'clock in the morning and then run exactly the same load test at 11 o'clock in the morning and the same load test under a 3 o'clock in the afternoon environment and see where the spikes are going to appear. Or as Bob said, actually, in a very valid point, you know, when they're doing the testing in the field, they'll run it for 24 hours. And they'll know that at that period of time at 3 o'clock in the afternoon, they expect it to spike because they know there's a particular process happening. Or at 4 o'clock in the morning when a particular DR task takes place, which is obviously going to spike anyway.
So this time we're going to be running our portal, still our portal read, but we're also now going to be executing queries. You could also have it going to a page with Excel services or performance point or info path or something else as well. I'm just going to choose IE8. I'm going through these pretty quick so we can see the output of this. So we'll add our computers back in. We'll add both SQL servers. We'll add in our 2 web front ends, web servers. All right, we're just going to get this started up quickly.
We should start everything. We should do crawling, UPS imports. We should just go for it and just get everything going. And I don't think it'll work, actually.
No. Don't think we have enough data.
I think we might find the intranet content source isn't popular.
It is. Oh.
You want to have the intranet back to sites.
Oh, it's not in the content source anymore.
Oh. We have a running.
That's entirely my fault.
Well,
Yeah,
we have that running.
Yeah. It's fine. There you go.
What is it, Steve? Intranet,
.isc London.local.
like such. Oh, they'll let you do all kinds of dodgy stuff, yeah. It won't work, you're saying? All right, there we go. So we'll see what's going on. Let's go back over to our testing host, and let's start taking a look at, still haven't loaded. The delay is weird. Usually it's not that much delay when we're doing testing. It's usually, I don't know, 20, 30 seconds. This is closer to 2 minutes, so I'm not sure what's doing it. It's your disk again. Should we go check the...
So what was the step load we did for this one?
So we started at 5 users, and I believe every 10 seconds we're adding 10 users. Now, real world, you don't want these steps much longer than 10 seconds, something like 15 minutes, or 30 minutes. So take a look at what 50 users is for like 30 minutes, and then step it up another 50 users for 30 minutes. But longer times essentially give you a better feel for your actual performance.
And one of the things you'll notice with the bell curve that come from step users that we don't see with concurrent is when you do concurrent user loads, obviously it's going to show you the impact immediately, so it's just going to be the flat line or be at whatever level it is. At least when you do step user loads, you're actually going to see at what point, at what concurrency that step over the red line occurs. So you're going to know, oh, at 57 users doing that, that's the point at which it's gone beyond what we accept it to be. So we can get a lot more control of that. So here we go, it's loading up.
You can see our request per second as it's starting to climb. Then we can also take, let's look at our computers.
Oh, look at our request per second.
And you can see...
239. That's better.
Yep.
We're getting there, right? So
What we'll
adding our second cores, we're now starting to get those that performance back into the page load times now. So that's starting to be a lot better. That's 256.
So now you'll... Go ahead.
Yes, no, I'm just happy with that.
Yeah, no, it's not bad at all. And you can see now what we're doing here on the bottom. The blue line is our request per second. We could also come in and add user counts, and we can now look at the performance of, say, processor as we add the users. So it gives you a nice, and you might want to add total users from overall at the top.
What's that?
It's under...
Which one do we want? What are we going to do? Add total users.
Scenario.
Yeah, scenario. Let's add the users from that. Come on, add it, add it.
It should just go.
Okay, there we go.
It's red. Yeah, it'll show up in a minute.
Yeah, it's waiting.
This gives you a good overview, though, of looking at specific counters. And as you add users and as you step up, you'll actually be able to see how your system is performing at each level. But generally, we have a specific requirement, and that requirement is I have a target that's 3-second page load time for 2,000 users, and let's say it's 10% concurrency. So what more and more, we're actually just testing for the requirement. But step load does give you an idea if your system's breaking, where it's breaking, without running multiple tests. But in the end, you should actually be able to run a test that meets the requirements. And remember, the requirements are going to be very different if your users are all local versus if they're coming across the pond, if they're coming over just from Boston, for example, over here. You know, having a 4-second page load time is not reasonable. So you may have different targets for different users in geographic locations.
That just doesn't want to show up.
Did you break it?
Yeah. It's not showing up. I just want to show the step user load as we were growing it up so you can see the users coming up and then the performance accordingly. Because you can see, if you look at the graph, when we hit that 80%, we got the warning, where we saw the CPU hit that warning level, and then after that, we kind of got spikes around the 90% mark. So what I wanted to show was at what users we were at when we hit that 60, then 80. Why is that not just going on? That's kind of bizarre. Huh. So normally, we'd get the user load there, and we'd see that user load as it was stepping in groups of 5 or 10 or whatever we've defined it for, and then that would also...
Wrong server. Oh, there it is. Scenario. No. It's just not working at all. That's awesome.
Yeah, that's really weird.
We've run this, I bet, 50, 100 times live, and that's always worked. So, go figure.
Yeah. I mean, the point is that's what we want to test it for, right? That's what we're looking for, is adding that user step so we can see it on the chart.
The other thing to note, you've got remote clients, and you've got, does anybody have like high latency, low bandwidth clients out there? So you can actually have the agent, the test controller, the agents can be on the other side of the pipe. So you could actually see what the response times are from those agents across the WAN. And that's going to give you much better results than just selecting some other network type when you're going through the load balance.
So memory's trundling along quite nicely, I noticed that. So it is literally the processor time that's the only issue we've got at the minute. So obviously the 2 cores is now starting to be stretched at this total concurrency.
And it's very likely when you start these testing that you'll fix one problem and you'll create another. So we could add 4 processors to this, and we would see processor no longer be an issue. It might become disk queuing. Or we add processor, and we actually see memory. We now don't have enough memory. And essentially, you're creating stress fractures in the system, and as you fix one, you can open up another. So it could take 3 or 4 or 5 iterations of this. We generally want to take a couple of outages 2 nights in a row, how we initially do these tests. We go in and get the requirements, we schedule an outage at night, we run our test, we run our fixes the next day, we come back and run it again. And it's really hard to overcome bad code as well. And that's one thing, Eric Schups here, you did that session here already, or is it coming up?
Well, we were going to try and do it today if we had time. I don't think we're going to have time.
We'll try it now? We got a few minutes? Are we out?
Yeah, we might struggle. We were going to try and get Eric to give us some code that was optimized.
But if you're responsible for the server farm, we shouldn't have any difficulty in finding out where there's some code that possibly is hurting us. And we don't trust this day and age, and I don't mean this to be bad against any third-party vendors, but you need to hear it straight. We don't trust third-party any different than custom code. We run it all through the same all through the same process of testing it, putting it on these servers, running through these tests, and validating their performance of their code. And just because they're a big third-party software vendor, there's no guarantee it's not damaging the performance of our farm.
That's a really good point, actually. The vendor software, if you're going to put third-party software into your SharePoint farm, my goodness, you've got to run this stuff and test it. And look at the impact of that software. It really will be immense, the difference some of those tools can make. And also notice on the SQL Server here, when we're just looking at the task manager alone, when we're running these tests, notice how we aren't really giving the SQL boxes any pressure at all here. I mean, we're not giving them any major spikes whatsoever. In fact, the CPUs really are quite idle at the best of times here. So we are going to have to do a lot more application traffic if we're really going to start hitting these particular SQL servers. But if we were to start firing up something like Performance Point, where we've got a lot more, constant traffic through business intelligence dashboards, for example, you'll notice that we've got, 16 gig of memory on these boxes? That won't be enough. If we start to scale out SharePoint and put 2 more application servers in, running Performance Point, running dashboards off 24, 32 gig each BI server, that is going to tank this SQL box at that point. So this might be okay handling our collaboration load test.
I mean, it's really common now that we're seeing the pressure on farms, actually on the web servers or the search servers, and less so on the SQL. And I think part of that, be interested to hear what the MCMs think down here, but is modern SKUs. You have a hard time buying a SQL server that's not 16 gigabytes of RAM and 8 cores. I mean, it's harder to buy a bad server nowadays for the money you spend on it. So more and more, and I think the other part of that is probably the customization, that people are doing more in the websites. They're doing more with web parts and custom code. But we're seeing most of the pressure, the big pressure we see on servers is out on the web servers and the search servers. That's probably where a lot of our performance tweaking has been going on, at least in the last couple of years.
So what we're just waiting for now, we're just going to wait for this thing to finish. We've just got a minute to go, and then we're going to look at the summary. Because what's going to happen on the back of this is it's going to produce a summary report that's going to show us all of the things that it's been doing in the background, and then it's going to give us all these statistics on things like requests per second, which of all the pages that you're hitting in your web test is performing the worst in terms of load times. So it's going to actually give us a lot more information that we can use as a report mechanism over a period of time.
Do you have any questions while we wait for this to finish? Yes. They have a box for this. Anywhere from a really nice laptop to a one-use server in a rack, depending on how much we're actually testing. Sometimes it's just one of the developer's machines, then we turn it on from the developer's machine to do the testing. But the larger the client, the more likely they are to have a dedicated box for this, yes. Question here?
If you wanted to do monitoring as opposed to testing, would you use Perfmon or would you use, say, a load test that's not actually doing anything, so it can store it in SQL and you get all these kind of metrics that come through?
Okay, that's a really good question, is if you were just trying to do monitoring. SCOM, System Center Operations Manager, actually has a baseline capability. So you could actually run your test, find the baseline, and integrate with SCOM. That would be probably how I would do it, the easiest way.
If it was like a one-off scenario, though, I mean, I know that you're talking about using PAL, for example, but I see for that you have to run Perfmon on each individual server and then get all the results from each server one at a time. And that's the nice thing I like about this is that you can, if you do it in Spike, you can drill into that 30 seconds.
I'm glad you said that.
Let's pull all these counters in.
So what we are, the great part about this is we're dumping it in a single database. You can go to CodePlex, and there's actually a report tool that runs on top of this content. So you can actually create if you run an SSRS, SQL Reporting Services, you can actually get a report off of this data, build off of everything you're collecting here. That's one way to do it. The other way is to copy and paste it out of here. There's actually not a good export for the data you have here, even though it's aggregated. So the CodePlex tool works pretty well, actually. We've used it several times.
There we go. So we've got our report now at the end of this load test. So this is really useful information because it's taking those statistics over the time frame that we've been running the test and giving it us in a nice report-friendly manner. So we can see the maximum user load get up to 150, test per second 70, how many failed, right? Because we also need to do the failure as well as the success. Pages per second averaging 284. That's not bad. That's not bad at all. Obviously, if we were doing anonymous access, see, again, you've got to think about types of web apps, right? If this was an anonymous access web application, I should be expecting that way higher than this.
That's right.
Which goes back to your caching point. Response time, average response time is 0.4 seconds. That's not bad.
Did you add 2 cores to both servers or just 1?
2 to both.
2 to both. Okay.
Yeah, each one went up to 2 cores each. We also see which pages were causing the largest page time to load. So we can see that the search results one took the largest time against the, in this instance, the home page.
And you can see the ratio there where the count is only 42-45 because it wasn't equally split between queries and page reads. But that was probably one of our largest performance hits. So, and especially as more and more we depend on search, that's going to become more critical in our farm.
When you start building your SharePoint farm, it's very important that you do map out the right services that you want to have from day one. Don't just install a lot of the services that you're not going to use. Even though you might not be using them, they could be consuming resources under the hood anyway, which is obviously going to skew these results that you don't want to see. If we go up to the top here and look at the key statistics, you'll notice that it says what are the top 5 slowest pages to load. So if you actually wanted to do a load test that was literally doing a browse action as a user, this is a really good way of finding all the poorly performing pages across your intranet, for example, as part of a load test. You could point it at some key locations, and that would be your baseline, and then check them again once people have done that customization of content on it. That's actually a really important one, isn't it? Intranet against collaboration. So when you're doing a web test against intranet, obviously we're going to optimize that for page viewing for users. When you're thinking of collaboration for site collections that are being used for, say, a projects web app, that's going to be different types of traffic to expect. So the statistics off the project site collection logic, you're expecting different types of results and loads. And sometimes you might look at it and go, oh, that looks kind of slow. But in context of what it's actually doing, it might be fine. But if you look at it from an intranet, you're thinking, gosh, that's really bad. That's when we start looking at like the actual graphics that Ben was showing earlier. And looking for
but
those
even
key
in a
features.
highly collaborative environment, you're going to get 5 reads, or I make up some number, but it's really high, 5 reads to 1 write. I mean, still most of your traffic's reads. I'm viewing a calendar, I'm looking at a list, I'm looking at tasks. It's still pretty heavily read-oriented.
And we can also see here that the test, out of the 2 web tests, so again, if you've got like 20 web tests that you're doing against the load test, it was rank and sort them as to which of your web tests was the one that caused the most performance grief. So we can see here that the query test was 3.3 slower and the portal was 2.48. So again, the query was the obvious one that was going to be performing worse than the...
Do we have another question? Somebody else?
We've got a couple of minutes. Does anybody want to ask a question before we break? We've got about a minute left, actually.
Actually, I think we're out.
Huh?
We don't have a minute.
Oh, are we done? Oh, sorry.
But if somebody had a question, if not, we'll still be around. So if you want to ask us, there's a ton of stuff we haven't talked about. You could spend literally all day showing different services and testing. So hopefully this is a good overview.
I mean, when I do this in my advanced admin classes, one of the things that we do over the period of time is we have groups of people doing different tests in different scenarios, and you do have like 3 hours. And it makes a big difference when you do those what-if scenarios over and over again and playing the same load test but in different scenarios with different applications. And that's kind of what we wanted to show you. Interject those different what-ifs. That's what's going to show you the real results of what you're doing. And plan accordingly.